How would you go about scheduling a network of synchronization jobs that all have specific requirements and interdependencies? I couldn't find a reasonable way to do it, so we wrote the most flexible data synchronization toolset available today. Our agents can be scheduled with a variety of requirements and codependencies. The agents are aware of each other. They can tell if other agents have valid or expired data. They have many different options for scheduling. You can schedule them at recurring intervals, for a given cron, or even multiple crons. You can set run limits per day. You can request execution from a remote source, like a database table. You can specify blackout periods, where the agent is disallowed to run even from remote requests. You can even assign behavior trees to further fine-tune the logic of how and when an agent can run. Let's take a look at the power of the task coordination available for sync agents. I've gone ahead and set up a single sync agent. You can see that with add agent. It's using a local file source for this demo. Typically speaking, you would tie this back to a database, and all of the records would be available to view, edit, and modify from there. I've assigned that source to our first agent, and I've said that you're allowed to run if you're past due. There are three main blocks when you're adding and configuring an agent. Those three blocks are configure agent, execution code, and the behavior tree check. We'll look at this one a little bit later. For configuration, I've said you're allowed to run once per day, and this is set on an interval to run every 5 seconds. With this configuration, when we start the application, you will see that the agent kicks off within 5 seconds, and it's only allowed to run once per day. Let's see this in action. You'll see that the pull data agent has completed successfully. It started 5 seconds after the application started, completed its work, and marked that it has valid data for the next 24 hours. Let's add another agent here that will run alongside our first agent called load Excel agent. It's using the same agent source, which is important so that they can communicate later. This time, instead of setting it to run on an interval, I've set it to run with a single cron. You can supply multiple crons if you'd like multiple crons to activate the agent. Let's go ahead and run this again. You'll see that within 5 seconds of starting the application, our pull data agent has started due to the time span. This is run on an interval, and it completed the load. You'll also notice that load Excel has also run, this time due to the cron that we supplied. It ran on the minute 0 mark. Both the agents completed and have valid data for the next 24 hours. Let's go ahead and add the other agent so we can see some of the task coordination available. This one's called execute refresh. This one's interesting because it can only run after the first two agents, pull data and load Excel, have valid data. That means data that is not expired. We've set this to run every 5 seconds, once per day. In this one, we have late binding behavior trees set. You'll see that's what this third block is for. If we're trying to perform a sync, we declare a new behavior tree. And that behavior tree says that both pull data and load Excel must not have expired data for this agent to run. Let's go ahead and run this so we can see this happen. You can see the first agent kicked off 5 seconds after starting. The next agent will run right on the minute 0 mark at 13:26:00. You'll notice that as the load Excel agent completes, our execute refresh agent kicks in as well. Our execute refresh agent starts because pull data and load Excel now have non-expired and valid data available. This is just one of the many ways that you can use sync agents. Check out our documentation page for more information. Thanks for watching, and we'll catch you in the next one.